To approximate the area of a region, we can add area of a finite number of rectangles. This process often requires adding up long string of numbers. To make it easier to write down these lengthy sums, we look at some new notation here called some sigma notation. The Greek capital letter sigma is used to express long sum of values in a compact form. For example, if we want to add all the integers from 1 to 20 without sigma notation, we have to write 1 plus 2 plus 3 all the way to 20. We could probably skip writing some of the term and write 1 plus 2 plus 3 plus 4 plus dot 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 plus 19 plus 20, which is better but still cumbersome. With the sigma notation, we write this sum as summation I from 1 to 20 of I. So each time when you plug in the value for I, you will get I equals 1, so 1. Then you add the plus sign next to it. I equals 2, so plus 2, and so on. This is much compact, and typically the sigma notation is presented in the form summation I from 1 to n a sub I, where a sub I describes the terms to be added, and the I is called the index. Each term is evaluated when we sum all the values, beginning with the value when I equals 1 and ending with the value when I equals n. For example, summation I from 1 to 4, 3 times 3 plus 2i to the third power. So how do we write out this sum? So we begin with I equals 1. So we rewrite the term by plugging in I equals 1. So 3 times 3 plus 2 times 1 to the third power. Okay, so in this one, I equals 1. Then, when you're done, you put the plus sign. The next value is I equals 2. So you get 3 times 3 plus 2 times 2 to the third power. The next value, I equals 3. 3 times 3 plus 2 times 3 to the third power. And the last value, I equals 4, and we stop because it ends at 4. So we get 3 times 3 plus 2 times 4 to the third power. So as you see, I is changing from 1, 2, 3, 4. And the location of I is right here. Then, you will just perform the addition as normal. Okay, so evaluate what's inside the parentheses first. 3 times 5 cubed plus 3 times 7 cubed plus 3 times 9 cubed plus 3 times 11 cubed. And then you evaluate each term. Okay, 3 times 5 cubed is 375, and you would call this as your A1, right? Then plus 1029 plus 2187 plus 3993. Okay, so that's your A1, A2, A3 to A4. So you represent this sum, this 4 number as the sum right here. And when you add them all up, it equals 7,584. This is the value of the sum. There are advantages of using the sigma notation. First of all, when you multiply a number to each term, you don't have to do it every single time. You can just pull it out of this sum, take the k out and just add up the smaller number and then multiply by k. Another advantage is if you're adding two sums or subtracting two sums. If they have the same number of terms, so I from 1 to n, then you would just add or subtract the term instead of the sum, and then sum it up. Another advantage is we do have summation formulas. For example, if you're summing up a constant n times, so I from 1 to n, so when I equals 1, the term ai is c. When I equals 2, the term is still c. So you add up c n times, then it just equals c times n. Now if you add up the number as what we see, right, I from 1 to n, earlier the example is I from 1 to 20 of I, right? So it's 1 plus 2 all the way to n when you plug in the I. This is a arithmetic sequence, and when you add up an arithmetic sequence, is n, the number of terms, times the last term plus the first term, right, n plus 1 over 2. And if you summing up I square, a square term, okay, so it's like 1 square plus 2 square all the way to n square, this is a formula, okay? This sum equals n times n plus 1 times 2n plus 1 all over 6. And we have a summation formula up to I to the third power. So if you summing up I cubed plus 1 cubed plus 2 cubed all the way to n cubed, the formula is saying the sum is n squared times n plus 1 squared all over 4.